The goal of this metric is to provide means for checking that the requirements specification is aligned with a predefined set of properties of the system conceptual model. The results of the metric will show the non-covered properties in the specification. At the end of the day, if the requirement specification is not fully covering the set of properties, a medium or low quality level value will be computed, so that an alert can be generated. In order to use this metric, at least two elements must be configured before it's used. First, which properties will be compared with the requirement specification, and then which requirement patterns will be used for analyzing the requirements with. These patterns are necessary because, as we see in the slide, we will compare the properties given by the system conceptual model with the ones extracted from the requirements through the patterns. This metric computes its value, calculating the ratio between the number of properties selected in the system conceptual model which are not found in the specification and all the selected properties in the system conceptual model. The returned result is a number between 0 and 1, representing the completeness coverage ratio. It means 0 means that nothing is missing in the specification, or in other words, that every single property selected in the system conceptual model has been found in the requirement specification. On the other hand, a value of 1 means that everything represented in the system conceptual model is missing in the requirement specification. Let's take a look at a brief sample scenario. On the one hand, the requirement specification is formed by the following requirements. Feel free to stop the video to read them. Note that some physical properties are defined within those requirements. We'll focus on the coverage of the temperature of some elements measured in degrees Celsius. Aside of the requirements, on the other hand, the system conceptual model defines some properties in the PBS, so that we have defined the temperature values for these 12 elements. The matching process will extract properties from the requirements, performing the coverage checking between the specification and the properties to evaluate. It only covers 6 out of the 12 properties, so there are another 6 properties not covering the requirements. In a nutshell, this specification is 50% incomplete for the property selected in the system conceptual model. Let's work a little bit now with the requirements quality analyzer in order to see how to configure, run the metric and finally check results. The first thing I'm going to show you is the requirement specification, which is exactly the same as the one we described in the slides. Next, what we are going to do is configure a new metric. So for that purpose, I come to project configuration and then to the completeness area. We have no completeness metrics yet, so I can create a new metric among the ones in the bunch of completeness metrics, so I will focus on the properties coverage. Let's give it a name. As I'm gonna check the temperature coverage of the composition of the engine in the PBS, I will give a descriptive name, for example. So, at this point, remember that we have to configure this metric with at least 2 different elements. First, the properties that we want to check in the specification, and then the requirements patterns that we want to apply to the specification in order to extract properties from the proper requirements. So, for the first one, we have to click on this configuration button in order to select the properties to cover. As I said before, I want to check the engine decomposition of the PBS. So I will select this view on the PBS. And finally, all the terms that I want to check. So I will select all the items of the engine. As you can see now, all the properties defined in the system conceptual model for the selected terms will be checked if they are covered in the specification or not. On the other hand, creating patterns is not the goal of this video, so just for you to know that I created some patterns by using Knowledge Manager, so that I will include them in this configuration. Finally, we got both the properties to check if they are covered and the patterns to apply to the specification. so that we have our metric ready. Let's go back to quality control in order to evaluate the just created metric. So I go to the completeness side. I have my metric here with no assessment yet. So right click and recalculate. And let's see what happens. The calculation is done, so we got one only star, which means low quality for this metric. Remember that we told in the slides that the result of this metric is a value from 0 to 1, in this case 0.5. This value is translated into a low, medium or high value through the quality function, which can be checked on the configuration for each metric. So let's take a look. If I select the metric here in the configuration, I got here the quality function. So the default quality function for this metric says that less than 20% of incompleteness is fine, so high quality. Between 20 and 50% of incompleteness is medium quality, and over 50% of incompleteness is not acceptable, so it means low quality. Since my metric got 0.5, which means 50% of incompleteness, it means low quality. Remember that these quality functions for every metric can be changed to whatever value you would like. Let's move forward and see why it scored low quality. Here we are. The first thing that we see is that we got 50% of incompleteness, which mainly means that 6 properties out of 12 defined in the system conceptual model were not found in the specification. So if we move forward, we can see which ones were not found in the specification, which are these ones. For example, the definition of the temperature for the carburetor and the rest of the elements. Second, on the right, we have information about how many requirements were covered by this metric. So it means that 66% of the requirements, in fact 6 requirements, generated at least a property that is configured to be checked in this metric. On the other hand, 11% of the requirements is not generating any property, and the 22% generated at least a property but not selected in the metric to be checked. Finally, the third view, which is this one, is the opposite. It says how incomplete could be the metric configuration. Basically means how many properties have been found in the specification that were not included in the metric. So if we take a look at it, we'll see that we have some properties found in the specification that were not included in the metric configuration. We have also the requirements viewpoint. It's the same information as we saw before, but from a different point of view. And at last, the filtering tab, we can see how many requirements that match with the filtering process. In this case, we did not put any filter, so all the requirements are matching filters. Of course, it's possible to create reports out of the metric results. These reports could be produced in both formats, PDF or Excel files. Up to now, we are able to assess how incomplete our specification is in terms of properties coverage. But I'm wondering if the specification contains out-of-range values for any property. I'm also wondering if the specification contains different values for the same property. These cases imply some consistency assessment, which is not the goal of these completeness metrics. For that purpose, we also provide the properties consistency metric, which is explained in another video. Thanks for watching. Goodbye.